Hello, everybody. Welcome to this talk. I'm very glad you are here. I know it's last time and you are with us. It's very nice. We will talk about WebAssembly. Of course, everybody is talking about WebAssembly those days, but also about design systems. And maybe this is a big new year for you. I'm Pierre. I'm the co-founder of Dila, the solution we will present to you.
And I'm Jean. I'm managing the technical part of our project. Thank you for being there, staying with us for a little presentation.
So let's talk about design a bit. Web design system, it's a way of for a designer to design something it can be reused between many projects. Instead of doing one project, one design, and repeating the process again and again, the designer can do like an agnostic, reusable design, and then it will be used on many implementation, many projects. So in design system, you have components like cards, buttons, sliders, style utilities, shadow, spacing, color system, and also other artifacts like the icon set, the layout and the grid. You can have a lot of things into the design. But web design system is not only about design, it's also about implementation. So the developer are implementing it once, and then they can use it in many projects. So a web design system is also some markup, templating, JavaScript, CSS, you can package and reuse. Maybe you know some of them, like Material Design from Google, very famous, Bootstrap, originally from Twitter, or the US government design system, which is very famous. For 10 years, Jean and me, we worked into implementing design system for the Drupal CMS, which is a PHP CMS. It was great, but why we were targeting the CMS? Because unfortunately, the universality of design systems works only for the design part. When you implement a design system, you need to target one stack. You will not implement it the same way if you are targeting a PHP app, a Python app, React, Salesforce, or AngularJS, for example. What we miss is a universal implementation, a universal packaging of a design system. 2 years ago, one of our clients, welcome everybody, it's never too late. 2 years ago, one of our clients came to us and said, "Oh, we love the design system implementation you did for us. We are using it 20, 30 Drupal project. Can we use it on a Java application?" So, no, you can't. It was not possible because implementation or targeting specific technology, specific web stack. What they ask is to have a single implementation, and then you load the design system, the executable design system, you load it in very diverse apps, Drupal, Java, React, for example. Is it possible? Okay, it is possible. That's why we are here and we show you. We did it. We will show you in a few minutes a package where a fully implemented executable, shareable design system is packaged. And you can load in headless rendering on browser, in server-side rendering, and with many, many languages, PHP, Java, Python, Ruby, you name it. It's comfortable, it's safe, you know why, and it's amazing. Let's do a little demo. So this is our website, and here you can see it's an alert component from Bootstrap. There was no specific binary loaded. That means it was rendered on the server side by PHP. And then, if we start to do some modification, you have real-time change because the change were rendered by JavaScript, some web component on the headless. So this file, the file you see here triggered 3 times, is the exact same file we are used for server-side rendering by PHP and now by web component rendering on the browser. This API, it's API using only nested mapping, only primitive. Boolean, string, numbers, mapping, list, only primitive. So you can build this message with any languages. And this API is very powerful because it's declarative, it's stateless. And for example, if I want to take this button and I want to nest it on my message, I have my button on the message. If I want to change a prop, for example, my alert is not dismissible anymore, I can change the prop. And it works like that, like, for example, a web component of a React component, but you have to understand that if you run it on a Python app on the server, it will work the same. We don't have only components. We have a lot of artifacts implemented. We cover a full design system. For example, we have a style utility system. If I want to apply this shadow, this big shadow, to the component, I can just add the little property about style and tell them to apply the shadow. It's not only concatenating text and doing adding attributes. There is logic inside. There is checks, logic, and also optimization in the rendering process. So this is what we do. If you want to know more and to test, we have a showroom, dila.io, with 8 public design systems implemented. So you can do everything I did and have fun.
Okay, so I'm going to talk a bit about our technical journey to come there before a component model. I'm going to repeat a bit because for us it's a bit crazy. We have a problem. We have a design. You have a design. You're using design systems principle, so you're hoping it's going to be shareable across all your web application, but it's not at the end. You have to do an implementation for each languages. You even have to do an implementation inside languages for each technological stack you have. And there is some languages with a lot of technical stacks. I'm not going to name JavaScript, but here we are. So from the outside, it's a bit crazy. You have to do the same tasks, the same job, implementing a boring job. There is no value in this job, but you have to do it for each version of your stack. And imagine when you have to update your design, that means you have to replicate the update in all the implementations. From the inside, it's like it is what it is, because there is no solution for that. It's normal. We have to do that. But in the outside, for us, it's a bit crazy. So we looked 1 year ago to find a solution for this problem. Is there somewhere in the wild a technology, something that can help us to make this design system universal and shareable? Do you have any guess? Oh,
yeah.
We are the
WebAssembly.
good conference. I was not sure. That's okay. So great, WebAssembly, it's here to give us what we need on the client side, headless rendering, what we had on the demo without latency. And I will talk about it later, with some important note on the size and the performance on what's produced for the client side. As a universal plugin system on the server side, whatever language, and it's isomorphic, you can have the same result with the same payload as you've seen in the demo, and even on cloud and edge version. So that's it. We decided to build one Wasm file for one design system, and we shipped inside what we called our renderer service that we wrote in Rust, because obviously because of the toolchain, and more important, because of the size of the Wasm produced in comparison to the functionality we can have with Rust, because we can talk about TinyGo And at the end, we made some tests, and we get a bigger Wasm file for the same functionality that we need in Rust. We have a template engine, because we need to work with template. We pick Jinja. And we have the design system itself, templates by themselves, and definition to give us the description of what's inside. And it went pretty well. But we got some first bump. The first bump, if you work with WebAssembly, you already know, it's only numeric parameters in export and import functions. And for us, it's a bit of a problem, because we need a complex data, like you see the payload, and we need a markup result. So at the time, and even now, there is some tweaks, a workaround for that, shared memory, and reading in the memory to fix this problem. So 1 year ago, we decided to start and to go with, for the client side, Wasm by Gen. And we have to praise the project a bit because they have a very good documentation. We ended up with very good performance and size on the Wasm. Something specific and pretty useful for use case, we can work with JavaScript object as input and output. Even if we are producing markup as output, we can include the markup in the JavaScript object because sometimes we have more information to ship than the markup by itself, JavaScript, assets, information for the design system. And it worked pretty well. For the server side, we decided to go with Xtism. I don't know if you know them, and then I have to praise them because they really gave us a solution for a problem. Very good documentation, very efficient, meaning they give the snippets, you use it and it works. And we made it work in PHP. On our website, it's on production for PHP. And because we are targeting more web languages, we are aiming to Ruby, Go, Python, and of course Node. And it was working very well. And of course, as you know, they have an incredible logo. So that's something important when you pick a library. But you can ask, why you didn't use Xtism for the browser? Because they can do browser as well. Because unfortunately, we had a problem on the size. Mostly 25% bigger for the same Wasm file than with Wasm Engine. And we have a little difference, which is getting better on the last version. We have done the benchmarks on the 1.02, I think, of Xtism. And each time it's going a bit better. But still, the size is not changing much, but the performance is better, and it's a slight difference. So that's it. At the end, our product, very simple representation, easy to understand, of our product. This is the on the left side, it's our internal kind of soup to prepare the design system to be ingested by our renderer engine. For the build, and this is where it's a bit annoying for us, 2 different builds to have one Wasm for Xtism that we can run then server side, and one Wasm for with Wasm Engine that we can use in browsers. And I have to mention browser, for example. We did some benchmarks, and on average, Firefox, no surprise here, is 20 to 25% faster than Chrome for the exact same thing on a clean setup and everything. So that's it. That's how Dila is working today as a ready product, and as you've seen in the demo.
So, it's done now. What more? It's perfect, and we are now delivering to the first client. So everything looks very nice. However, we can do better. Wasm by Gen and Xtism are not perfect. The main issue is we have 2 builds. We told you that we target only one build, one Wasm file by design system. And now we have 2. And also, the 2 builds are not providing a perfect, unified developer experience for the people who use the Wasm and load them in the app. And also, using the memory of the Wasm module to interact, even if it's done by the Wasm by Gen and the Xtism wrapper, was not very comfortable for us. We wanted to directly interact with the Wasm file. So we looked for a solution, And since January, one is very obvious. The 25th of January, there was a lot of release, a lot of activity on the web ecosystem, WebAssembly ecosystem, especially on the Backcode Foundation, but not only, because what happened this day was the release of Wasm Preview 2 and the component model. So you all know what is a component after 2 days, but this is our understanding. We have a module. Still, this is a module. This is a limited API of the module, memory, export, import with only numeric. And the component is swapping the module inside the same Wasm file, providing an interface type data with a rich API and only export and import function. So for us, it was perfect because we were able to ship this file and to connect to all the language we wanted. Also, there is many types into the component model, but if we look only the fundamentals, we have the 6 types we need. Remember, we are only using language primitive. We want our API to be used with Python primitive, JavaScript primitive, PHP primitive. So those types are here, and we are very happy about that. However, it was not an easy road. We didn't start on January. We were ready on January to jump onto the component model. We started 1 year ago, and every month we were rebuilding the app around the component model, and every month it was breaking. Of course, it was work in progress. The specification was not ready, the implementation were not ready, so of course it was breaking, but we tried anyway, and we got every month some surprise, but no, it must work. It was released, so let's see if it's really working.
Okay, so this is a more bumpy path of a technical journey trying the component model. So before, it was working, and it's now, but the problem, 2 builds to run. With components, at least we reduce only 1 build to run. And we did it, and it was working well with cargo component, you probably know, because now we really love the way it's working. Instead of Wasm Bindgen creating bindings and Wasm from the build with placeholder, with cargo component build, the bindings is included in the build. So you don't need bindings after. You can use the Wasm directly, which was for us very interesting and match our use case. Even if it's not stable, it's working. So we go with Jco for the JavaScript browser. So now, at this point, we are using Jco, but the hope, I guess, for us, is for component model to be included in the browser directly. So we don't need Jco. The browser can directly read the component. Because now, what Jco is doing, if you use the transpile command, you have your component created from a build, single component, and it's extracting the module and converting the type for JavaScript. So as you can see, it's a bit coming backward because you get the Wasm module instead of using directly the component. But it's working. For the server side, we go with Wasm time because it's a reference implementation. It's the one working with Preview 2. In comparison, as far as we know, currently, there is no other runtime with WASI2 implementation. Sometimes it's planned, sometimes it's not started, sometimes there is discussion. But still, we got it working. We got it working with the command line, which unfortunately is not our use case, but it's working. We get it working with Python, but unfortunately, with Python and Wasm time pi, it's generating a binding for Python. Again, the thing we try to avoid, the binding. But it's working. And for other languages, it's either started, work in progress, and for us, PHP is important for us, and unfortunately, now there is no Wasm time support. So that's our point on the running. But again, the same schema for product, but it's way better. The first part didn't change, but what's really important for us and good for us, it's only 1 build. 1 Wasm component file at the end that we can use and ship and serve to the client and say you can use it everywhere and run it everywhere. So for now, it's almost run everywhere. Soon, we get with Gco, it's working very well with good performances. You can even get rid of the wrapper depending the context and use for Node.js and use Wasm Node.js implementation, which was surprising for us because they have, if you don't know, they have a Wasm implementation since Node.js 12, and it's still in progress, and it's getting to the preview 2. For now, it's preview 1, but it's getting to the preview 2, but because Gco is doing a module again, not a component directly, we can use it. But still, it's pretty good performance for us. And the only kind of burpee of hole in the road we have now, it's more for the languages. Python, it's almost there, but for Go, Ruby, and the other, unfortunately, it's not there yet.
So, the conclusion. Is it successful or not, this component model for our use case? Eh bien, not yet. The main issue is we are not able to plug the one-time runtime with the language used by our clients. So everything else looks good, and we have a proper API without memory tweaks. The performance is still good. The size is good enough, and we hope it will get even better. But now it's not ready. So what we did is we kept Wasm Backend and Exism on our website. We are planning to remove Wasm Backend soon, this spring, and to replace it with a component model and GCO. But we will keep Exism for as much as we need, because there is no rush, and we love Exism. But I hope one day we will have only one build for everybody. And there is Steve from Exism who said that anyway, until the browser are not supporting component model, it will not be the solution of the community, which I kind of agree. When we will adopt the component model, so maybe next year, we will show you our adoption. We can enjoy the composition. We've seen something about composition yesterday. It will be wonderful to take two design systems and to merge them together. For example, you are building a display with material design, and up inside you are printing a card from Bootstrap or for Fluent Design from Microsoft. It will be also wonderful to split the Wasm in between features, so it can be à la carte for the user. And also it will be wonderful to plug a component with business logic, Wasm component, to the design system instead of host language. Also, we are expecting the component model to be ready to use a registry. Today, we are shipping the design system package into a static HTTP server. It's good. This is a web. It works. But we've seen yesterday the wonderful presentation of warg and wav.dev, and we want that. We want safety, and we want the self-documentation, and we want package management. So, someone said this week, WebAssembly is not is a solution looking for a problem. And it's true, we talk a lot about solution and not so much about use case. But I disagree. We got a business issue. It's not us who said, oh, let's go to WebAssembly. It's the client. The client say, we want this implementation. Find a technology who can do that. And that's why we went to WebAssembly. So it's, for me, for us, design system are a perfect use case for WebAssembly because it's a single executable shared in full information system of a client using the same branding. So if you are tired about maintaining different design applications, if you want to know more, if you are curious, if you want a demo, please come to see us after or this afternoon, even this evening if you want. We can do as much demo and explanation as you want. Also, when we picked WebAssembly 1 year ago, it was just like, okay, this is the suitable solution. This looks good. But 1 year after, we are in love. We are convinced. And being with you this week, it's even increasing our interest. So we can work on different projects with WebAssembly. Don't hesitate to contact us. And finally, we are managing meetups event. I am managing the one for the French speakers in Europe. And the next meeting is in May in Brussels. So if you are around, you don't hesitate to come. And it's bilingual. That means if you don't speak French, it will be in English.
Someone is not speaking French?
Yeah, everybody speaks French.
Come on.
Yeah. You are born speaking French. You just forgot to speak. And Jean is managing the Lisboa, Portugal meetup, and we are looking for a sponsor to host the next event. Thank you very much. Do you have questions?
Oh, one question.
I'm curious what were the factors of choosing template engine?
Yeah. The Jinja templating engine. So,
Oh, yeah, very good question.
Yeah, very good question.
Oh, so I can answer on this one.
Okay, nice.
It's because we were looking for different, and because we started on Rust, we looked at Terra, we looked at Ascama. Ascama was the most efficient in performance because it's including in the build the template, but we had a problem because you need to describe your template before in Ascama, and we don't always know. We have to prepare the design system, and we need a bit of dynamic build for the templates. So we went on Jinja. At the time, he was starting to make Jinja. The mini Jinja Rust is made by the guy from Jinja. So we must praise him as well because he has done a crazy job to make it work. And we picked this one for comparison with Terra because of the size. At the end, Terra was way bigger, and we got a better size with Jinja.
Yeah, but also, why Jinja at the beginning, and why this kind of templating? Because we want something which is working both for server-side rendering and headless rendering. So we want something to express the logic of the template and the markup in a stateless way. We were avoiding, for example, JSX, because JSX is a stateless language, but it's very easy to make it stateful. So it's dangerous for us because once it starts to be stateful, we are not able to run it server-side anyway. If you are from the React world, you know there is a React server component, and it's such a mess right now. And also, JSX is a full-feature language. It's a JavaScript. And us, we wanted to have only an engine with a very domain-specific language, so we can control everything happening on the execution part.
Yeah.
So a design system is not just the looks and feels, it's also behavior. So for example, Material has this ripple effect on the button where wherever you click, it crosses the animation. How was it to port something like this? Was it hard? Was it easy?
We didn't implement this. It was with Material web libraries we took. So us, when we take a design system, we are not rewriting the CSS and the JS and everything. We take as it is. We do two jobs. First job, we are templating the markup. We are instead of having a static file, we are templating it. Second job, we are describing what is happening. Because for when you are doing a query with the payload, there is a lot of logic happening to be sure the CSS, JS, and markup return is the most suitable. And this logic is based on definition of artifact. This is the component, the slot, the props, how they work. This is the style utilities. This is the variables. So we need to describe everything in order to the renderer service to do the rendering.
So to make it more simple, at the end, on the output, we have the renderer markup, and we have the assets that you should load, style, JavaScript, with this component, the global one and the single one that sometimes are cheap just with this component. We are giving this information on the output. Yep.
So were you able to make it work with one of the JS frameworks somehow? To create like a wrapper for this? Or?
Yeah, with React. It's working. We get a component React with use effect. We have it working, and we have a snippet working. But you can see later. I think it's going to be too late. But we have it working live on our website with JavaScript and React and web component as well. We made a little snippet wrapper for web component, and it's working. Okay. Thank you very much.